everyone, welcome to our online class. So in today's class, sequential series in M1 Engineering Mathematics 1, in one video I explained previous year questions, correct? From 2008 to 2020, I explained all previous year questions, what type of questions he gave, and I also explained how to solve those questions, which test we have to use, those all are explained, right? Now so many students are asking solutions of these all questions. I thought you people will practice and will clarify the doubts and all, but it's okay. So many students are asking solutions for this all problems, okay? So in this video I will explain those all problems solutions. Just go through this video and practice these all problems, and this will be helpful to you for your upcoming exam, okay? So I am solving first 2008 paper questions. In that first easy problems I am solving. So in 2008 total he gave 8 questions, right? Different sets he gave 8 questions in that. So this is one question, sigma 1 by n into 2n plus 1. So right, test for convergence, sigma 1 by n into 2n plus 1, right? So how to solve here? First of all, see what we have to do first. Let un is equal to what? 1 by, multiply this one 2n square plus n, right? So which test it is? It is not in the form of geometric test r power n. It is not in the form, that you need to check, right? It is not in the form of r power n. It is not in the form of n power p. So now next, which test it is? We have comparison test, right? So I told you follow the order and all, right? Correct. So we have to follow the order. So it is not in the form of r power n. It is not in the form of 1 by n power p. So next, which test it is? It is a comparison test, correct? So total how many tests we have? We have geometric test, we have geometric test, we have p test, and we have comparison test, and D'Alembert's ratio test, Rabi's test, correct? Cauchy's, these all are tests are there. So go through these all definitions, so then start these problems quickly practicing. So what we have to do now? Select Vn. Vn is equal to what? Highest nth term numerator of un. There is no n here. Take 1. N power 0 you can write, and denominator it is what? N square. N power 0, anything power 0 is what? 1 by n square. Which form it is? 1 by n power p form. 1 by n power p form. That means what is p value here? P is equal to 2 is greater than 1. P is equal to 2 is greater than 1. If p is equal to 2 greater than 1, so what happened here? So therefore sigma Vn is convergent by which test, by p test, correct? Sigma Vn by p test. Now what we have to do? Actually we started comparison test, no? In comparison test what we have to calculate? You need to calculate limit n tends to infinity un by Vn. Now by comparison limit n tends to infinity un by Vn is equal to limit n tends to infinity. What is my un value? 1 by 2n square plus n. What is my Vn value? 1 by n square, correct? So this n square will go to numerator, limit n tends to infinity, n square, and here take out n square common, 2 plus 1 by n square got cancelled, If you apply the infinity, 1 by 2 plus 1 by infinity, anything by infinity is 0, 1 by 2 is not equal to 0. So therefore sigma un is also what? Convergent. Why? Since sigma Vn is convergent. What is the definition of comparison test? Sigma un and sigma Vn, two series of positive terms, and limit n tends to infinity un by Vn is not equal to L. Limit n tends to infinity un by Vn is not equal to L. Then sigma un and Vn both converge or both diverge together, correct? So like this you need to solve this problem. First you need to test whether this problem is, which test you have to use. Whether it is in the form of r power n, no. Whether it is in the form of 1 by n power p, no, correct? Then you need to go for third test, comparison test. So we started with comparison test, and for comparison test we need un and Vn. Un he gave already, so Vn is equal to what? Highest nth term numerator. There is no nth term here, n power 0. Denominator highest nth term is what? N square. Any n power 0 is what? 1 by n square. It is in the form of 1 by n power p. What is p value? P is equal to 2, so greater than 1. So therefore sigma Vn is convergent by p test. After that what we have to do? By comparison test, limit n tends to infinity un by Vn you need to calculate, okay? So limit n tends to infinity un is what? This part, and Vn is what? This part. Take this part to numerator, take out common of n square, n square get cancel. So apply the infinity, n tends to infinity, 1 by infinity is 0, 1 by 2 not equal to 0. That's it. Simple problem now. Okay. So next problem. Okay. See the next problem. Test this problem also is there in 2008 question paper. Test the convergence of sigma 1 by n power 3 by 2 plus n plus 1 ma. Right. So how to solve? Same no. Let un is equal to 1 by n power 3 by 2 plus n plus 1. So it is not in the form of r power n. It is not in the form of 1 by n power p. So you need to start with Vn. Comparison test you need to solve. So select Vn is equal to highest nth term. There is no nth term numerator. So take 1. Denominator it is what? N power 3 by 2. Which form it is? N power p no. So p is equal to 3 by 2 is how much? Greater than 1. So therefore sigma Vn is convergent by which test ma? By p test. Correct? By p test. Now what we have to do now? By comparison. By comparison limit n tends to infinity, what we have to calculate? Un by Vn you have to calculate. Limit n tends to infinity. What is my un value? Un value is what? 1 by n power 3 by 2 plus n plus 1 by 1 by n power 3 by 2. This will go to numerator. So this is equal to limit n tends to infinity, n power 3 by 2. Take out n power 3 by 2 common ma. If I take common here I get 1. So here what I get here? N get cancelled, 1 by n power 1 by 2 plus 1 by n power 3 by 2 I get. So this part get cancelled. If I apply the infinity, anything by infinity 0, anything by infinity 0, 1 not equal to 0. 1 not equal to 0. So therefore sigma un is also what? Convergent, since sigma Vn is convergent. Correct? By comparison both should be converged or both should be diverged together. Right? So take down. Next problem. Test the convergence of sigma square root of n cube plus 1 minus square root of n cube. Here there is no denominator. No, this already this type of problem we did in our previous videos. No problem. We will do one more time here. See, first what we have to do ma? Let un is what? Square root of n cube plus 1 minus square root of n cube. Then what we have to do? You need to rationalize. No. So what I am doing directly ma. Okay. So you take one more step. So square root of n cube plus square root of n cube plus 1 by square root of n cube. I am rationalizing square root of n cube plus 1 square root of n cube, right? So what happened here? Un is equal to a minus b into a plus b, a square minus b square. A minus b into a plus b is what? A square minus b square. So what we get here? We get square get cancelled, n cube plus 1 minus n cube by square root of n cube plus 1 plus square root of n cube. N cube got cancelled. So comparison we have to use. Select Vn. Vn is what? 1 by root n cube. That means 1 by n power 3 by 2. So it is in the form of n power p. So p is equal 3 by 2 greater than 1. So therefore sigma Vn is what? Convergent. Identifying the type is important, right? If you know how which type it is, so you can solve quickly these all problems. Convergent by which test it is? By p test, right? Now by comparison. So what we have to do? Limit n tends to infinity, un by Vn is equal to limit n tends to infinity. What is my un value ma? Changed one. 1 by square root of n cube plus 1 plus square root of n cube by 1 by square root of n cube. This part will go to numerator. So therefore this is equal limit n tends to infinity root n cube. If we take common of root n cube here, can we take common of root n cube? We can't take, right, we can take, no. So n power 3 by 2 it becomes, so 1 plus 1 by n power n cube under root plus 1, correct? Root n cube get cancelled, you get 1 plus 1, 1 by 2 not equal to 0, right? So therefore sigma un is also what? Convergent, since sigma Vn is convergent. Correct ma? Like this you need to solve this problem. Understood this problem, right? So rationalize, very important problem on this method. On rationalizing he gave 3-4 problems are there. Just to solve these problems ma. Right? Next see the another problem. Okay, next problem. test the convergence of 1 by 1 into 3 into 5 minus 1 by 3 into 5 into 7 plus 1 by 5 into 7 to 9 minus 1 by 7 to 9 into 11 plus so on ma. So which test it is? Plus minus plus minus. Which test it is? Alternating series. Correct. So he didn't ask solve by Leibniz or something like that. So he just say test the convergence. So we can solve two methods. So one is Leibniz, other one is what? Alternating series. So I am solving this problem using alternating series ma. Okay. So solution, what is our nth term here? Let un is equal to minus 1 whole power n minus 1 by how to find nth term ma? 1 3 5 7, right? So 1 3 5 7 is what? A plus n minus 1 into d, no? How to find a plus n minus 1 into d? So a is 1 plus n minus 1, 2n minus 2. It is what? 2n minus 1 I am getting. So first term is what? 2n minus 1. Next one is what? 3 5 7. That means 3 plus 2n minus 2. So I am getting 2n plus 1. Then third term is what? 5 plus 2n minus 2. I get 2n plus 3. This is our nth term, right? So if you take n is equal to 1, how much I get? I get 2 minus 1, 1, 3 and 5. If I take n is equal to 2, I get 3, 5 and 7. Understood? How we calculated nth term here? So nth term is what? Minus 1 whole power n minus 1 by 2n minus 1, 2n plus 1 and 2n plus 3. Correct? So in alternating series, what we have to do ma? Let mod un. If I take mod un, this negative term will become positive, right? Negative term will become positive. So I get here 1 by 2n minus 1, 2n plus 1 into 2n plus 3. Correct? Now which test it is? It is not in the form of r power n. It is not in the form of 1 by n power p. The next test is what? Comparison test, right? So in comparison test, what we have to do? You need to calculate Vn, right? In comparison test, we need Vn value. So what is Vn value here? So select Vn. Vn is equal to highest nth term is what? 1. Here n. How many n's we have? 3 n's are there. So 1 by n cube, 1 by n power p. P is equal to 3 is greater than 1, right? So P is equal to 3 greater than 1. So sigma, therefore sigma Vn is convergent by which test ma? By P test. Correct? Now what we have to do? By comparison, limit n tends to infinity mod un by Vn ma. Mod un by Vn. So limit n tends to infinity. What is my mod un value? 1 by 2n minus 1, 2n plus 1, 2n plus 3 by 1 by n cube. Correct? This n cube will go to numerator. N cube will go to numerator, right? So n cube will go to numerator. So what I get here? So this is equal to limit n tends to infinity. N cube will go to numerator. Take out n common, n common, n common. If I take n common, 2 minus 1 by n, and here n common, 2 plus 1 by n, and here one more n common, 2 plus 3 by n. N cube got cancelled. If I apply the infinity, 1 by infinity is 0, 1 by infinity is 0, 3 by infinity is 0, 2, 8 is not equal to 0 ma. Correct? Not equal to 0. So therefore sigma mod un is also convergent. If sigma mod un is convergent, then sigma un is what? Sigma un is absolutely convergent. So therefore sigma un is absolutely convergent. Like this, you need to solve this alternating series problems. Understand here how to solve. So first what you have to do, identifying the type is very important ma. So plus minus is given. It is what? Alternating series, right? So already we did this type of problems in my previous videos, right? So take down this problem also. I'll solve the next problem. Next problem ma. Test the convergence of the series sigma x power n by n power n minus 1. Okay. So whatever the repeated problems are there, I am not explaining ma. Okay, just go through those all repeated problems. The remaining problems I am explaining. Now see here. So first what we have to do, let un is equal to x power n by n power n minus 1. Right. So I am taking here Cauchy's nth root test. By Cauchy's whole power n is there, no? So by Cauchy's nth root test, what we have to find? Limit n tends to infinity un whole power 1 by n. So this is equal to limit n tends to infinity, x power n, this can be written as n power n into n power minus 1 whole power 1 by n. That means separate it, no, limit n tends to infinity is coming, yeah, it's coming. One second, let me make it down. So x power n whole power 1 by n is one part, n power n whole power 1 by n is one part, n power minus 1 is what? 1 by n whole power 1 by n. N got cancelled, n got cancelled. If I apply the infinity, x by infinity into 1 by infinity whole power 1 by infinity. One second. So anything by infinity will give you 0, 0 is less than 1. If it is less than 1, what we say? We say convergent. So therefore sigma un is convergent. Okay, understood this problem? So this is the one more problem. Okay, next another problem. See the next problem. Sigma n plus 1 factorial whole square x power n minus 1 by n. So what we have to do, let un is equal to n plus 1 factorial whole square into x power n minus 1 by n. So x is there, start with the D'Alembert's ratio test. So let un plus 1, if we take un plus 1, what it get here? N plus 1 plus 1, n plus 2 factorial whole square, x power n plus 1 is what? N by n plus 1, correct? So what we have to do now? By D'Alembert's ratio test. So therefore here it is square, no. Now by D'Alembert's ratio test, by D'Alembert's ratio test, what I get here? Limit n tends to infinity, un by un plus 1 is equal to limit n tends to infinity. So un is what? N plus 1 factorial whole square x power n minus 1 by n. This will be, I am writing reciprocal, n plus 1 by n plus 2 factorial whole square x power n. So now how to simplify this one? Limit n tends to infinity, n plus 1 factorial whole square x power n into x power minus 1 by n into, take out n common, 1 plus 1 by n by n plus 2 factorial can be written as n plus 2 whole square, n plus 2 whole square into n plus 1 factorial whole square x power n. So n plus 1 factorial whole square, this part get cancelled, x power n get cancelled, n got cancelled. If I apply the infinity, 1 plus 1 by infinity by x into infinity, you get infinity square. Anything by infinity is what? 0. Anything by infinity is what? 0. Infinity into x is what? Infinity only. Anything by infinity is what? 0 is less than 1. So therefore sigma un is what? Divergent. Sigma un is divergent. Like this you need to solve when the problem x is given. Okay, take down. Next problem. Okay, next problem, see here. So what we have to do? Next problem, let un is equal to n cube minus 5n square plus 7 by what I get here? N power 5 plus 4n power 4 minus n, right? So which form it is? It is not in the form of r power n, it is not in the form of 1 by n power p. It is what? Comparison test, you need vn. So what I'll get here? Select vn. If I take vn, highest nth term is what? N cube, and here n power 5. So what I get here? 1 by n square. It is in the form of 1 by n power p, correct? So 1 by n power p, p is equal to 2 is greater than 1. So sigma vn is convergent by which test? By p test, correct? Now what we have to do now? By comparison, correct? Identifying the type is important. By comparison, limit n tends to infinity, un by vn is equal to limit n tends to infinity. What is my un? N cube minus 5n square plus 7 by what is my vn? N power 5 plus 4 n power 4 minus n by 1 by n square. This n square will go to numerator. So limit n tends to infinity, take out n cube common here. If I take n cube common, 1 minus 5 by n plus 7 by n cube whole divided by n power 5 is common, 1 plus 4 by n minus 1 by n power 4 into n square. So n cube, n square, n power 5 got cancelled. If I apply the infinity, I get 1 not equal to 0. So therefore sigma un is also what? Sigma un is also convergent. Sigma un is also convergent. Since, why convergent? Since sigma vn is convergent. Understand? Like this you need to solve this problem, right? Okay, next. Next problem, test the convergence of the series sigma n plus 1 whole power n into x power n by n power n plus 1, 2009 problem. So what we have to do first, let un is equal n plus 1 whole power n into x power n by n power n into n I am writing, right? So whole power n is there, take Cauchy's nth root test ma. So by Cauchy's nth root test, by Cauchy's nth root test. So what I get here, limit n tends to infinity un whole power 1 by n is equal to limit n tends to infinity un whole power 1 no, n plus 1 power n whole power 1 by n, x power n whole power 1 by n, and here n power n whole power 1 by n into n power 1 by n, right? So see, this n got cancelled, this n got cancelled, this n got cancelled. So if apply the limit n tends to infinity, n common ma, 1 plus 1 by n into x by here n power 1 by n, correct? N got cancelled ma. So if I apply the infinity, so what happened here, 1 by infinity 0, x by infinity 1 by infinity, anything power 0 is what? Infinity power 0, right? Infinity power 0, anything power 0 is what? 1. I get x. So now how to write x? If x is less than 1, convergent. 3 cases no. If x is greater than 1, divergent. If x is equal to 1, what are the test fails? Like this, you need to solve this problem. Okay, you can solve like this, or else now if you take x is equal, if you ask you for a long answer, what you have to do now? If you take x is equal to 1, test fails no. So if you take let x is equal to 1, if you take x is equal to 1, un becomes n plus 1 whole power n 1 power n by n power n plus 1 mark, correct? Now which test it is? Which test? Comparison test. Select vn, right? So vn is equal, here highest nth term n power n, and here n power n into n. N power n got cancelled. 1 by n, it is in the form of 1 by n power p. 1 by n power p mark, correct? So by using Cauchy's nth root test, we got x. X is based on 3 conditions. X is less than 1, convergent. X is greater than 1, divergent. If x is equal to 1, what? Test fails. So I took x is equal to 1. So I selected vn, highest nth term n power n, and denominator n power n into n power 1 mark. So n power n cancel, 1 by n power p. P is equal to 1, less than or equal to 1. Sigma vn is divergent. So since, therefore, sigma un is also divergent when x is greater than or equal to 1. Like this you can solve. Otherwise by comparison you can find out, and the limit will get limit n tends to infinity un by vn is equal to not equal to 0 you should show. Like that also you can solve. Okay, not equal to 0 you can show and you can solve ma. Like this also you can derive this problem. Okay, next problem ma. Next problem, this problem is there in 2010 ma, 2010 sigma. I am not solving similar problems ma, please go through it, please be careful. I am not solving this similar problems, I am solving different problems. So now sigma x power 2n minus 2 into n plus 1 into root 2, this is in 2010, right? So what we have to do first, let un. So what is un here? X power 2n minus 2 by n plus 1 into root n, correct? Now what you have to find, you need to calculate x power n un plus 1. So what is my un plus 1 ma? X power, if I substitute n place of n plus 1, 2n plus 2 minus 2 get cancelled. I get here n plus 2 into root of n plus 2, correct? Now what you have to do, by D'Alembert's ratio test. So by D'Alembert's ratio test, what you have to find, limit n tends to infinity un by un plus 1 you have to find. So that means limit n tends to infinity, limit n tends to infinity, what is my un value? X power 2n into x power, I am separating, n plus 1 into root n whole divided by this, no, this will go reciprocal, n plus 2 root n plus 2 by x power 2n. So x power 2n got cancelled. So what I get here, x power minus 2 means 1 by x square. So n, take out n common ma, 1 plus 1 by n root n is as it is, this x power minus 2 will come x square, and here if I take n common, 1 plus 2 by n, if I take n common, root n into root of 1 plus 2 by n it becomes. So root n cancel, n cancel, x square is as it is, right? So limit is there, limit is there, right? So if I apply the limit n tends to infinity, what happens? Anything by infinity is 0, anything by infinity is 0, 1 by x square I get 1 by x square. Now what is x value? We don't know. What is x value? We don't know, right? So in this case, what we have to do? You need to assume, right? If 1 by x square is greater than 1, convergent, correct? If 1 by x square is less than 1, divergent. Then if 1 by x square is equal to 1, what it ma? Is equal to 1, test is fails. Test fails. So what we have to do? Let x square 1 by x square is equal to 1. Okay. So what we have to do ma now? Let 1 by x square is equal to 1. That means x square is equal to 1. Un becomes x square whole power n, no, 1 by n plus 2 into here x square is 1, no, so 2 is common, n minus 2, so 1 power n minus 2, so 1 by n plus 1 into root n. So which form it is? Comparison test. So select Vn, so 1 by n root n will give you 1 by n power 3 by 2. So correct. So this is in the form of 1 by n power p. P is equal to 3 by 2 is greater than 1. So sigma Vn is convergent by p test. See here, we started with comparison test. So again after that we took the conditions x square is equal to 1, then it is converted into comparison test. So in comparison test, what you have to find? Limit n tends to infinity un by vn, no. So limit n tends to infinity un by vn. So limit n tends to infinity, this will go to numerator, no, n power 3 by 2 by I am writing directly 1 plus 1 by n root n. So this part root n got cancelled, 1 not equal to 0. So therefore sigma un is convergent. When it is convergent? 1 by x square greater than 1, that means x square is less than or equal to 1, x square is less than or equal to 1. Like this you need to solve this problem. So divergent when x square is greater than or equal to 1. Very important problem, very important problem. Practice this problem. Understand here how we solve this problem. Okay, so take it down. I am not solving similar problem. So in 2008 also similarly there is one problem is there. So you can solve it same way like this. Okay, fine. Okay, see the next problem. Test the convergence of the series sigma x power n by n factorial or 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on. This problem is there in 2015 and this problem is there in 2020. So the both problems are same. Here he gave the series and here he gave directly nth term, right? So first in solution what we have to do? Let un is equal to x power n by n factorial. Then x is there, un plus 1 becomes x power n plus 1 by n plus 1 factorial. Correct. Now what we have to do? By D'Alembert's ratio test, limit n tends to infinity un by un plus 1. Limit n tends to infinity un by un plus 1 is equal to limit n tends to infinity. What is my un? X power n by n factorial. This will go to numerator n plus 1 factorial by x power n into x power 1. X power n got cancelled. So this is equal to limit n tends to infinity. N plus 1 factorial can be written as n plus 1 into n factorial by n factorial is as it is into x. N factorial got cancelled. If you apply the infinity, what you get? Infinity plus 1 by x. Infinity by x is infinity is greater than 1. So therefore sigma un is convergent. Like this you need to solve this problem. Understand? Okay, we'll see next problem. See the next problem, important problem. Test the convergence of the series sigma n plus 1 sigma n factorial whole square x power 2n by 2n factorial. Okay, so how to solve this problem? Same. So let first un. What is my un? N factorial whole square into x power 2n by 2n factorial. Correct. So un plus 1 you have to find out, no, what it becomes? N plus 1 factorial whole square into x power 2n plus 2 by 2n plus 2 by 2n plus 2 factorial. Right. This is un plus 1. Now what we have to do? By D'Alembert's ratio test. By D'Alembert's ratio test, limit n tends to infinity, un by un plus 1 you have to find out, correct? So limit n tends to infinity un by un plus 1, limit n tends to infinity, what is my un value? N factorial whole square x power 2n by 2n factorial into divided by this, no? So this will go to numerator, 2n plus 2 factorial can be written as 2n plus 2, I am writing directly, 2n plus 1 into 2n factorial. Don't write it in exam directly, just solve. N plus 1 factorial whole square can be written as n plus 1 whole square, n factorial whole square, x power 2n into x square. Okay. So by we are solving so many problems, that's what I wrote directly. Don't do like that. Okay. So write stepwise. So 2n factorial got cancelled, x power 2n got cancelled, n factorial whole square got cancelled. So if I apply the infinity, what do you get here? Okay, see here, limit n tends to infinity. If you take n common, 2 plus 2 by n. If you take n common, 2 plus 1 by n. In the denominator, if you take n common, n square, 1 plus 1 by n whole square into x square. n square got cancelled. If you apply the infinity, what you get? 2 2s are 4 by x square you get. Now what is x value? We don't know, right? So what we have to do? You have to write the cases. If 4 by x square greater than 1, convergent. If 4 by x square less than 1, divergent. If 4 by x square is equal to 1, what becomes? Test fails. Test is failed. So what we have to do? Let 4 by x square is equal to 1. This implies x square is equal to how much? 4. If you take x square is equal to 4 also, D'Alembert ratio test is what? Fails. Correct? So D'Alembert ratio test is fails. So what you have to do? What you have to do now? By rabies. By rabies you have to do. So whenever D'Alembert ratio test is fails, you need to solve rabies test. So therefore by rabies, limit n tends to infinity, what you have to find? N into un by un plus 1 minus 1 you have to find. Correct? By rabies, limit n tends to infinity, un by correct. So what I get here? So this is equal to limit n tends to infinity, n into un by un plus 1. Before applying the limit, acha, we cancel it, no? How much you get here? 2n plus 2 into 2n plus 1 by n plus 1 whole square into 4 minus 1. X square is 4, no? So before applying the limit, you need to substitute in place of x square is what? 4. This part is as it is. So therefore this is equal to, it's not coming, we'll start from here. This is equal to limit n tends to infinity, n into what is LCM here? 4n square plus 4, 8n. So 4n square plus 2n plus 4n, 6n plus 2 minus 4n square minus 4 minus 8n. Right? So 4n square got cancelled. Limit n tends to infinity, n into 6n minus 2n minus 2n, right? So take out n common, minus 2 by n by n square common, 4 plus 4 by n square, 8 by n. So n square got cancelled, you get minus 2 by 4. So is less than 1. Correct? Is less than 1. So if it is less than 1, what happened? It is a divergent, no? So therefore sigma un is divergent. When it is divergent, when 4 is less than x square, that means x square is greater than or equal to 4. X square is greater than or equal to 4, it is a divergent. If x square is less than 4, it is a convergent. Like this, you need to solve this problem. Here it is x square or x square, because you gave 2 power n. Correct. Like this, you need to solve. Very important problem. This one is very important problem. Take down this problem. Okay. Next. Okay. Next problem. Test the convergence of the series 1 minus 1 by 2 root 2 plus 1 by 3 root 3 minus 1 by 4 root 4 plus so on. So it is what? Alternating series, no? So alternating series, so let un is equal to, how to write? Minus 1 whole power n minus 1 by, it is what? N root n. Correct? So mod un you have to take mod minus 1 whole power n minus 1 by n root n. It becomes 1 by n root n. That is directly in the form of n power 3 by 2 1 by n power p form, p is equal to 3 by 2 is greater than 1. So sigma mod un is what? Convergent by which test? By p test. So therefore sigma un is absolutely convergent. That's it. Simple problem it is. Okay. This problem is there, and the same similar one more problem he gave. The same problem, one more problem he gave, 1 minus 1 by root 2, 1 by root 3, 1 by 4 ma. So okay, you copied this one. Okay, next one is what? 1 by like this he gave, 1 by like this he gave, 1 minus 1 by root 2. So what you get here? You get only n. You get 1 by root n. You won't get this. So you won't get this. Here you get 1 by 2. Correct. So it is 1 by 2. What you get here? Less than 1. So here you get divergent. Then it is conditionally convergent. That's it. This is a problem number 3. Simple it is. Don't do it in the notes like this. So just take down this as another problem. Okay. So this is one problem he gave. See, if you know the test, no, you can play with this all problems with very quickly, right? So similarly, next one more problem he gave. Similarly, what is another problem? He say 2 square, then 3 square, then it is what? 4 square. So this is problem number 14. Now here there is no root, right? So you will get here n square. Correct? N square you get n square, means here it will come n square. That means it is in the form of 1 by n power p. So p is equal to what here? 2. So 2 is greater than 1. If it is greater than 1, we say convergent. Then this becomes absolutely convergent. That's it. Simple problem. These all are alternating series. How simple it is, right? So these are the one problem. So see, within seconds we did 3 problems. So next there is one more problem. One more problem on the alternating series. Next alternating series, another problem. See here. So what he gave, sigma n is equal to 2 to infinity minus 1 whole power n plus 1 square root of n into n plus 1 into n plus 2. Okay. So now first let un is equal, this is un, so I am taking directly mod un. Mod un is what? So when I take mod, this term will go off. So it is what? Root of n into n plus 1 into n plus 2. Correct? So now this is comparison test. Select Vn. If I select Vn, what happened here? 1 by n cube means n power root n cube I get. So 1 by n power 3 by 2. 1 by n power 3 by 2. So this is in the form of 1 by n power p. So p is equal to 3 by 2 is greater than 1. So therefore sigma Vn is convergent by p test. Correct? If sigma Vn is convergent by p test, then what we have to find? By comparison. Correct? By comparison, limit n tends to infinity, mod un by Vn you have to find. So limit n tends to infinity. What is your mod un? This part, no, 1 by root n into n plus 1 into n plus 2. Correct? So this will go to numerator, by Vn. This will go to numerator, root n cube. So take out common here. So root n cube. If you take n common, n cube, root n cube will come common. What is left here? 1 plus 1 by n, 1 plus 2 by n is left. So root n cube will cancel. If you apply the infinity, 1 by infinity 0, 1 by infinity 0, 1 into 1, 1 not equal to 0. So therefore sigma mod un is also convergent. Therefore sigma un is what? Absolutely convergent. If it is convergent, then sigma mod un is convergent, then sigma un is what? Absolutely convergent. Like this you need to solve this problem. Okay. Okay ma. So in today's class we'll stop till here. So these are the few problems I solved in previous year question papers. In the next video I will solve another remaining questions of previous year questions ma. Okay, practice these all problems. So go through our videos. In that also we covered some problems, right? So we'll meet in the next class ma. Thank you.